All right. Most of these questions we've been doing so far really just involved your calculator. Unfortunately for this one, you will have to know some facts. All right. Believe it or not, there are some math facts, algebra 2 facts you need. Just can't rely on the old calc. All right. So this one comes from this year. I'm giving you cosine is 7 over 25. We are in quadrant 4. They give me this sine squared plus cosine squared equals 1, and I'm looking for, hey, what's the value of tangent? Now, yes, you can't use your calculator, but you can eliminate 2 answers before I even start. I'm asking you to find tangent in what quadrant? 4. Little all students take classes. So what do I know about tangent in the 4th? It is negative, so goodbye choices 3 and 4. 50-50 shot now. We're not guessing, absolutely not. And again, if it's not multiple choice, we got to know how to do it all out. So first thing I need some reminders about is, and this board is driving me insane today, so there may be a point today where I literally pick it off its hinges and give it a toss. So just be aware. Anybody remember what tangent was equal to at all? I'll just go throw it out there. Tangent. Opposite over adjacent. Got it. Y over X. I love it. I'm looking for a sine and a cosine, though, what it's equal to, because that's what I'm using in the problem. Nice job. Sine. Tangent is sine over cosine. And your battle is halfway done, because what value did I already give you? Cosine. So you can stick 7 over 25 in that denominator. What we need to find is sine. What are we going to use? Actually, you know what? The more I think about this, I don't know if we really need to use this. I don't, guys, because what quadrant are we in? We're in quadrant 4. Everyone remember how to make a right triangle in quadrant 4? Bow tie if you forget. Where can I place the 7 and the 25? If it's cosine. Cosine. Adjacent, 7. And hypotenuse, 25. What can you guys use to find the missing side, which I am going to need? Pythag, go right ahead. 7 blank 25. So you guys can use Pythag. I should have realized that 5th period. Sorry, 5th period. We use that formula they gave us, but it's not a big deal. But I think this is a little easier for you, though. And that missing side, yes, I'm hearing people belt it out, is 24. I'm looking for sine now. Ooh, hold on, 24. Where I put that bad boy? Going down? Negative? All right, what's the sign then? Opposite over hypotenuse. So negative 24 over 25. Come on. Now you guys can skip, flip, somersault if you want to figure that out, or you can just go to your calculator and do 3 fraction templates, alpha y equals, and figure out of the 2 remaining choices, which one do I have? And you guys are figuring out it's going to be negative 24 over 7. Okay, so we all good? Y eliminated the first 2 there, 3 and 4. and then how I got here. Questions from you guys? Because that's the only one we have time for today. We got a big day today. Anything? Okay, next thing I've been meaning to talk to you about this for a while, and that's the whole lending out of the calculators, right? And I'm not upset. I may get fired up when I talk about this, but I'm not upset. Please don't take it that way. I'm just letting people know, if you borrow a calculator up here, you got to realize once Regents time rolls around, it's just not you guys taking it. It's you guys in period 5. And I only have 4 calculators. All right. So I'm just telling you, if you have your own graphing calculator, please start bringing it in every day and knowing how to use it. Okay. Because here's the situation I'm going to be put in. 6 kids need to borrow 4 calculators. How am I going to figure out the right way, the correct way to divvy them out? The fair way. I'm not. And so my response is going to be nobody can have them. All right. If there's more than 4. So if you have your own calculator, start bringing it in every day and using it. Because I can't guarantee I can let you borrow one day of the Regents. All right. We all good? Okay, next thing I got to ask you guys is Wednesday, we're going to have our unit test on probability, Wednesday. I'd like your opinion on how you want the review structured tomorrow. Would we just say, okay, here's what's on the test, and then you guys review questions with whoever you want to work with? Should I go over all the review questions in class? Or should it be a mixture of here are some doing them with me, and then you guys have the rest of the time to yourself? What do we prefer? So kind of doing some of the tougher ones with you, and then you guys have the rest of the time to try it out on your own. Okay. I'm good with that then. I'm good with that. All right, moving on. Do you guys have any questions from the assignment over the weekend with the given probabilities? A given B probabilities. Hi, Kylie. Number 4. You got it. Everyone go to number 4. Actually, you know what? Everyone go to the front of your packet because I need you to write down a formula you're going to need to remember going into Wednesday's test. All right, so right on the front of your packet, probability of A given, remember that vertical line was given B. I can't tell you how huge this is. Not only forget the test Wednesday. This is where if the Regents is going to ask a probability question, it's going to be this, the conditional one. So if I give you, find the probability A happens given B already happened. Do we remember how to find that? What goes in the denominator? Not in the denominator. Just B. Whatever's already happened. Already is B, so you're going to put the probability of B on the bottom, or however many B is. So the probability of B in the denominator. Whatever happened goes in the denominator. On top is both of them happening. All right. So the probability of A, and I'm going to start using the symbols now, and B. All right. Remember that was my intersection. That's and. Okay, so please remember that as I do the one Kylie just asked and as we go through today, because it's going to be a big part of today. All right. One more time there. 4, you said, Kylie? The old spinner. All right, you guys ready? And everyone, even whether you tried this or not, you can help us out. This is just basic conditional probability. So probability, you land on a perfect square given it's already even. So on the bottom, what's already happened? What's already happened? Even. So how many evens do I have there? Because that's my denominator. I have 4. 2, 4, 6, 8. So I have 4 on the bottom. Now on top, how many are perfect squares and even? How many numbers on that spinner are perfect squares and even? The number 4, right? So this is just 1 out of 4. Okay, because remember, it's not out of 8 anymore. It's out of all the evens. So here's what we're doing. we're taking 2, 4, 6, and 8 on the spinner and saying, now, what are your chances of getting a perfect square? 1 out of 4 chances. Good? Everyone else, all right? All right. What about odd, given that it's prime? All right, what's already happened? Prime. How many? Remember, 2 is the first prime number you come across. So how many primes do I have? 1, 2, 3, 4 primes. And out of those 4 primes, how many are odd and prime? Here's prime, 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 prime. How many are odd? So 3 out of those 4 primes are odd. No more out of 8. You okay? Sure? It's going to be a big one on the test and on the regions. Anything else you guys have for me? How's everyone doing? Great weekend? What did I do this weekend? It was all right. Nothing out of control. I behaved. Nothing stronger than ginger ale. Even though I don't drink soda, Kylie, at all. Fun fact about your teacher up here, last time I had a sip of soda, June of 1999. My graduation party from high school. So what do you drink? Water, milk, Powerade, Gatorade. What do you mean?
I don't drink milk.
Really?
Yeah.
Wow. That's the first time I heard that. Now, with me, like, I only would drink it if it goes well, paired with something. Like, I just can't have it. Like, usually at dinner time, I don't drink anything. I just don't. No, I'm not that kid. That just and it's like all over your face, and no, my daughter tried doing that a couple weeks ago. I was like, just stop that. Just, you're done with the cereal. Just stop. All right. Anyway, anything else? Going? Okay. Let's get to today's stuff then. Last day of the unit. Last day of this tough unit. And I know I still have your quizzes. I'm going to hand it back tomorrow as part of the review. All right. I just didn't wait to give it back today answering questions, so we'll do it tomorrow before the review. All right, let's do this. Here's what we got to do today. I'm going to give you a story and 2 events at the end, and I need you to tell me, are they independent or dependent? And here at the top, you guys don't have this, but here's the only thing you know about independent and dependent right now is if it's independent, you're going to put the object back in the bag or the box or the urn or whatever. All right. Dependent, I keep it. I eat it, whatever the case is. All right, we remember that? Independent and dependent. If I replace it, it's independent. If it's dependent, I didn't replace it. But here's today. There's no replacing of anything. I'm not even going to mention anything being replaced or not replaced. So how can we figure out if it's independent or not? Here's how we're going to do it. It's another formula. I apologize. Here's how we're going to figure out if 2 events are independent. Okay, this is how we're going to test if it's independent or not. We're going to say the probability of one event times the probability of the second event. If they are independent, that should be the same probability as, ready? The probability that both of them happen at the same time. All right. That should be true only if they're independent. The left and the right side should be the same. And there's a second way we're going to test today too. By the time you guys leave, you figure out which one you like better, the test. All right. But for right now, we're going to do both ways, every problem. Okay. You could say the probability of A. See, this is what's driving me nuts. Of A given B. All right. I just went over 2 of those problems with Kylie, how to figure out that probability. is equal to the probability of A. Those two should be equal if they're independent. It doesn't matter if B happens or not. Probability of A will be the same. You guys all right working kind of, you want to stay in your groups, you work with the people you've been working with here? Just stay? All right, let's go. Let's just stay then. Good, read through the repair shop then for me. Read through the repair shop. At the end, I need you to tell me what two things we're going to test if they're independent of each other or not. Okay, what are the two things we're going to test if they're independent or not? What are the two things we're going to test? Transmission fluid and brake pads. All right, so if transmission fluid and brake pads are independent of each other, we're going to use this definition up here. The probability of one of them, let's say transmission fluid, T, times the probability of the other one, brake pads, should be equal to both of them together, happening together. Now you're going to notice I'm not going to put anything in between because I don't know what the relationship is yet until I do some calculations. All right? If these two sides are equal to each other, they are independent. If they're not, they're dependent. All right, so somebody help me out. What's the probability you get transmission fluid? I believe I gave that one to you. 0.38. So 0.38 times, what's the probability you get brake fluid or brake pads? 0.28. How does that compare? 0.38. 0.28. How does that compare to both? What's the probability you need both? 0.16. Now you're just going to compare the two. Is that left side equal to the right side? If it is, they're independent of each other. If they're not, they depend on each other. And what are you finding out? 0.1064 is not, take a look now, is not equal to 0.16. So is transmissions and brakes independent of each other, or do they depend on each other? They depend, yeah. Getting brake pads does somewhat depend on if you need transmission fluid. So these two are dependent of each other. I can't win here today. I just want to write the word dependent. That's all I want to do. All right. Second way we could have tested, and remember, we're going to do both ways of testing it so you can decide on which one you want. Second way, stay on that same problem. Second way of testing it. We could say the probability of, and the order doesn't matter what you put first or second, transmission fluid given you have brake pads should be the same as the probability, look up above. What should this probability be the same as if they're independent? Transmission given brake pad should be the same as probability of transmission. All right? Let's compare those now. We know what the answer is going to be, but I want to do it two different ways. All right, look back up. What's the probability you get transmission fluid? 0.38. All right, so 0.38 over here. And this is just good practice. Somebody help me, remind me, how do I find this probability again? Friday, what we did Friday. Probability of T given B. What should go on the bottom? What already happened? What already happened here? What did I, brakes, right? I'm giving you brakes, so what's the probability of brakes so I can put it in the denominator? 0.28, and what goes on the top on these type of probabilities? Both, so transmission and brake, 0.16. 1.6, and now I'm just going to compare these two now. And you're finding hopefully not even close again, right? 0.57. Not equal to 0.38. So they're dependent again. So either way, you can test whether they're independent or not. Questions? In your groups right now, I'd like you to do parts A and B for me. Actually, you know what? Let me do part A with you. You can do part B in a second on your own. So part A, no independent or dependent. Ready? No independent or dependent. I just want to know what's the probability you have brown eyes given you already have blonde hair. So this is something I could have asked Friday of you. What's already happened? You have blonde hair already. So according to my chart, what's the probability of blonde hair? 0.35. That's that number down here under total for blonde. So 0.35. And what's going to go on top? Both, right? You have brown eyes and blonde hair. So what's the chances you have brown eyes and blonde hair? 0.10. I wouldn't leave it like that. Try to leave it as a decimal or a fraction. I left mine as a fraction, 2/7. Was that 0.28? Anybody? As a decimal? Okay. So about a 28% chance that you have brown eyes given you already have blonde hair. Now in your groups, go ahead and do part B. Probability of red hair given green eyes. Hey, giving the gingers some love here, huh? I don't have anybody in here, so that's how I can say that. Give some love that's stealing souls, right? Too harsh? Just take a look at that chart. Not too many. It's like Bigfoot having red hair and brown eyes. Is that just the can't to do both? It's like Christmas. It's like Christmas. Even though period 5, I did have a red hair, brown eyes in that class. So it wasn't 0.00. That they do exist. This was point. I did have a brown hair, brown eyes, red hair person in period 5. What'd you put on the bottom here? 0.25, the green eyes on the bottom. And probably they both green eyes. I have 3.6, 3/5. Ah. Okay. We all good? All right, now go back to the dependence. Does having green eyes depend on if you have, I'm sorry, does red hair have some dependence on green eyes? I don't know, let's check. Let's use the first definition, which is the probability of, go ahead, pick one. Which one do we want to start with, green or red? All right, so the probability, I'll put RH for red hair, times the probability of green eyes. What are we going to compare that to see if it's independent or dependent? Probability of red hair and green eyes, yep. All right, let's see if they're totally separate or they actually do depend on each other. Everyone all right on my setup? All right, somebody help. Red hair. 0.2 times green eyes. 0.25. And red hair and green eyes. 0.15. All right, are those equal to each other? So 0.15, what do you got for me on the other side? 0.05. So does one depend on the other? Yeah, they do. There is dependence here. They are not totally separate of each other. And I have a feeling you guys are just going to pick this way to use all the time instead of using the other one, so we'll keep it that way. All right. Are we ever going to have a problem where they're independent? You're darn right we will. Hey, gender, favorite subject. Yay. Yep. 57 sixth graders, huh? Good times back in the day, right? Sixth grade. Okay. I don't know. I would say the same thing for English, but just my opinion. Consider I never really learned how to revise a paper until my freshman year of college. Revising a paper, like rough drafts. All right. Anyway, so part A, does it appear that math as your favorite subject has dependence on a student's gender? Okay. So does it matter if you're male or female if you like math or not? So let's test it. So we're gonna have to do one for male, one for female. All right. What any preference on where to start? Okay, you got it. So is liking math and being male independent or dependent of each other? All right, so we'll go math and male first. How can I test? Everyone help me out. I can find the probability of, give me one of the events. Probability, you like math, times the probability. You're male.
Oh.
And what are you going to compare that to? Math and male. All right, use your table now, everybody. Use your table. What's the probability you like math? 18 out of 57 times the probability you're male. 8. 10. How many males? Probability you're male. Calm it down there, Yoga. 27 out of 57. And then what about math and male? 10 out of 57. Yep. Yep, go. Okay, math. Here's my math column. There's 18 total who like math. Out of good. Males. There are 27 of them total out of 57, right? And then how many are math and like math? Yeah. How many are male and like math? 10 out of the 57. And if they're independent, when I multiply the two separately, it should be equal to the two together. What else here? You sure? So what happens when we multiply these? Is that out of 57? Check the decimal though. Just don't assume because the fractions have different numbers on top and bottom. Check the fractions. Check the decimals, please. What are you guys noticing? They're not the same, right? So those are dependent on each other. What about now? Go ahead, test female now. So female in math. All right, here you go. Ready? Probability female. How many females? 30 out of 57. Math we already did on the other side. That was 18 out of 57. And now how many are math and female? 8 out of 57. All right. Are those sides the same? What are we finding out? Nope. Once again. So what can you tell me about gender and liking math? Oh, they do. They're dependent, which means your gender does affect if you like math or not, remember. All right, so there is, yes, there is dependence. You and your group, now change it to social studies and gender. Go ahead, social studies. Doesn't matter if you're male or female if you like social studies. What's that? I would like you to, yes. Yes, yes. Please do it in the B area. Kids are silly, I'll tell you. Gender, yep. Same thing, except now we're going social studies. A little history. There's our boy back here. It's unacceptable. Unacceptable. Finally, huh? Finally. Not that you got it right, Dom. I didn't mean that, but check those decimals. You'd be surprised. I don't think you did. to disagree with you. I want to check those again. No, you just did. All right. All right. Can't just go by the looks of the fraction. Yeah. Hey, everybody, huh? Finally, huh? We got two events that are independent of each other. Keep going. Yes. It does not, if you're male or female, if you like social studies or not. Has no effect on if you like social studies or not, because both of them come out to be the same. Keep trucking, though. It should come out to be independent. So they are not dependent, they are independent of each other. What do you got? You should have found both sides equal. Okay, where are we? So what did you do first? Probability you're male, right? So there, in total, there are 27 males in here, right?
Okay, yeah.
27.
And then 9 out of 57 goes on this side.
That's both male and, calm down, I'm teaching. 9 out of 57, yes.
Okay, I just put it in the wrong spot.
Okay, and when you multiply them, that decimal will equal that one. Okay? How we doing back there, man? Are we doing all right back there in that crew? Missed out on you, Ian, on Friday. Still got to show me the notes, though. And the missing Algebra 2 Regents questions we did. All right, so make sure you show me that. Three full weeks left, huh? Before break. 7 weeks from Thursday, we're sitting down, taking a bite out of this exam. Thursday, 12:30.
What's the date?
24th January. There's no conflict of interest. You're being there. Not on the 24th, because you're going to have to take it in June, and we do no reviewing in June. Yeah, exactly, because I don't even sniff this Regents at all, Algebra 2 stuff. We got better things to do. All right, we all good? One more to go? All right, this one's might be a little challenging here. No story, no nothing. Here's A, here's B. See if they're independent or not. All right, sorry, no backstory here for it. So are A and B independent if I give you this information? All right, so you're going to start this out with probability of A times probability of B. How does that compare to probability of A and B? And when we run into a problem, somebody just scream it out and let me know. Probability of A, 0.6. No table needed. It's right there. Probability of B, 0.5. Probability of A and B. No. That's not an and symbol, is it? That's my or symbol. Darn it, I can't use it then. That's my or symbol from Friday. Do not plug in 0.8. So what the heck do I do? Because I need this value of A and B. Go to the front of your packet, please. Write down this final formula on how to find A and B. So does everyone agree I'm missing this value and I need it to see if they're independent or not? So here's how we are going to find A and B if I ever miss it. So the probability of A and B, everybody ready? Is going to be the probability of A plus the probability of B. We've done this before. We've just never wrote it out this way. Minus the probability of A or B. That's how you find the and. Okay, so go back to that problem now. A was 0.6, B was 0.5, and subtract out 0.8. So what's the A and the B here? 0.6 plus 0.5 minus 0.8. 0.3. All right, let's compare them now. So how does 0.6 times 0.5 compare to 0.3? They are equal, which makes A and B independent. Yeah. So that's the only thing I may change on you is I don't give you everything you need. You just got to find it off to the side. Big day tomorrow. Big review day tomorrow. Big review day. Good to see everybody today.